In this demo, we are going to show how Veeam Kasten for Kubernetes can protect your Postgres EDB operator-based databases as per this detailed blog. The EDB operator covers the full lifecycle of your highly available Postgres cluster with a primary and standby architecture. Kasten will protect the EDB namespace where those clusters have been deployed. When Kasten via a blueprint initiates a pre-backup command, the EDB operator will fence off the secondary replica. Kasten will then perform the backup of the entire namespace. Once the backup is complete, Kasten will initiate the post-backup, which will then tell the EDB operator to unfence the secondary. From a restore point of view, labels on the PVC will let the EDB operator know it has to restart from this replica. Kasten restores the entire namespace. Let's now jump into the demo to show how this works. The first thing we're going to do is install the operator. A simple command to get everything that we need. We're then going to just show that we've created that new operator namespace. As you can see, we have that Postgres SQL operator system. We then want to create our EDB namespace, which is where our cluster is going to run. So we create that EDB cluster next, which deploys everything that we need within there. As you can see, that cluster example sets up that primary with a definition of what we want that to look like. And if we do this simple little watch on there and speed this up, you'll see that we create the replicas, the primaries, etc. that we just discussed. So as soon as that's all in a healthy state, we now have an EDB cluster running in our Kubernetes cluster. We're going to now install the plugin, basically for cloud native Postgres, and get that deployed. We're also going to create a client certificate to that database, and that gives us the accessibility that we need later on. We're then going to create a client so that we can interact with that cluster. Forget about the warning here. I'm using Talos Linux as my distribution. It's just going to give a pod security warning. We're going to then dive into our client or into our database and create some data. So to do that, we're going to exec into our client, and from there, some pretty simple Postgres SQL commands to add some data for the purpose of the demo. So we connect to our database, and then we can add some pretty basic data into our table, into our database. There we go. You see that we have some data. So now we can exit out of that. We have some data in our mission critical database. The next thing is to install that Kanister EDB Blueprint that we mentioned, and this is for the hooks, basically. This is for the pre and post hooks that we discussed right at the start with the images, with the diagrams. So within Kasten, we have our newly discovered namespace, our EDB namespace, and from there we can create a policy to protect that workload. We can define the schedule. We can enable an export out into our S3 location. In this instance, I'm going to a Wasabi S3 bucket, and we can then enable the resource filter along the persistent volume to basically say we're going to hit that secondary that we discussed again in that diagram. And from here, this is where we start to add in those hooks that we just mentioned. So whether it be a pre-hook or a post-hook, again defining what we discussed earlier about what that will achieve. Ultimately, that pre-hook is going to inform and hook into the secondary, and then from a post-hook, it's going to communicate back to the EDB operator and say we've completed this successfully. So we've created that policy on a schedule, and yes, we want to continue. And again, from a Kasten point of view, we're going to protect everything in that namespace. So not just the PVCs, but equally we're going to protect all of the objects that are created as part of that cluster. Again, we're going to speed through this. So first of all, we take that backup. That's going to be a snapshot on the local system. In this instance, this is using Rook-Ceph, but then I'm exporting that copy of that data out into an external S3 bucket in Wasabi. And we've now got a copy in two different places, either the snapshot for really fast recovery or from the S3 bucket, which also then enables us to restore to different locations. So you see here, I'm running a kubectl get volume snapshot in that EDB namespace, and you can see that we have that snapshot, although it looks a bit messy. So if we actually go ahead and create a bad day in the office and we delete that namespace, you'll see our namespace is now no longer discovered by Kasten. However, if we go down to removed, we'll see that instance that we had. So now we can restore that. But in deleting that namespace, we also deleted that volume snapshot. So we have to go to our Wasabi S3 instance. Now I want to restore absolutely everything back into our cluster. So with that, we can hit that restore and bring everything back into our cluster. So we can be granular, we can bring back what we want. You can see all of the artifacts that make up our application or make up our EDB cluster. Obviously the important part is that single line item that we have within our table that we want to get back up and running. So if we do a little watch command on our EDB namespace, we're going to start to see, and I'll speed this up again, we're going to start to see components, artifacts, objects coming back, or pods coming back into the mix, whether it be our client, but equally those three clusters those three nodes within the cluster that we had. Now the important part though is we need to confirm that our mission critical data is there and available to us. And again, we just exec into our pod, we connect using pSQL or SQL commands into our database, and the suspense should be showing that hopefully we have our data back. If I could remember how to put in environment variables. So now we connect to our database, or we are already connected to that database. We look at that links, and there we go. We've got our data back up and running. So with that, check out the blog post. But yeah, hopefully that was useful.